Okay, we made it to problem 12. Let's see here. It says consider an experiment X where you flip 2 coins and then roll a 6-sided die. Let the sample space of the coins be H and T, and the die be S2, S1, which is H and T for the coins, and S2, which is 1, 2, 3, 4, 5, 6 for the dice. Write the sample space S of the experiment X in terms of S1 and S2 and calculate its size. Does it consist of equal probable outcomes? Yeah, if they're fair dice and fair coins. So part A is to write S in terms of S1 and S2. Well, I flip 2 coins and roll a 6-sided die. So it's S1 cross S1 cross S2. And so this is the set of all triples. Let's call them A, B, and C, such that A and B are elements of S1, H and T, and C is an element of S2, which is 1, 2, 3, 4, 5, 6. Okay? So, again, just driving home the point that the sample space is generally going to be a cross product. And the size of this sample space is the product of the sizes of the sets that go into the cross product. 2 times 2 times 6, which is 24. Okay, 24 possible outcomes, and yes, they're equal probable. If the coins and the die are fair. And I've mentioned in class that unless stated otherwise, you do assume that they're fair. So we have the equal probable event or equal probable outcome case, which simplifies everything. Sorry about this wiggling thing. Let's see, what does part B ask? Consider the event E1 of flipping 2 heads and a 6. Well, technically I'll write it HH6. Okay, write this event down as a set and calculate its probability of occurring. The probability of E1 is the size of E1 all over the size of the set, which is 1 in 36. Okay, equal probable. There's only one element in that set. For part C, it says consider the event E2 where the 2 coins have the same value and rolling a 6. So either we have HH6 or we have TT6. Okay? And the probability of E2 is its size all over the size of the set S, which is 2/36 or 1/18. Okay? Part D says consider the event E3, 2 coins having different values and rolling an even number on the die. Okay, I can do that also. This is the 2 coins have different values and an even number. So I'm going to do HT2 first. Then I'm going to do TH2. So there's my even number, and I've got both possible ways of having 2 different coins. And I'm just going to repeat the same thing for 4 and 6. HT4, TH4, HT6, and TH6. Okay? And calculate its probability. Again, its size all over the size of the sample space, 6/36, 1/6. Okay? Let's see. Does that make sense? Yeah, there's sort of a... It makes sense now that I wrote it down like that. I'm not sure how you argue it otherwise. Part E says consider the event E4 which is E1 intersected E2. Oh, okay, yeah. Write this event down. So it's HH6 intersected with HH6 TT6, and that happens to be HH6, which is in fact E1 because E1 is a subset of E2. Okay, when one set's a subset of the other, their intersection is the smaller set. Write it down or calculate its probability is the same as probability of E1. There, I'm still on 1/6. I'm sorry, 1/36. It's getting late. Finally, E1 union E2, E5 is E1 union E2. Boy, I could have given you a more interesting. I could have used E2 and E3 in some of these things. E1 union E2 is HH6. It's equal to E2, H and TT6. And so the probability of E5 is equal to the probability of E2, which was calculated up here to be 1/18. Okay, well, I hope that gives you everything you need for the midterm. Hey, I didn't print out the graph theory problems for this midterm. You know that? So, but I'm out of steam, and so this is the last video I'm going to make tonight. I wish you guys luck tomorrow. Thanks for watching the videos. Hope they help.